So hello guys, in this video we are talking about Apache Spark data skew. And so let's start. What is data skew? Data skew is happen when data is unevenly distributed across partitions. Some partitions had more data than others. So how to identify data skew? First, we have first method. We have to go Spark UI. It is most reliable. Step one, go event timeline. Then see the summary of matrix table. Means go to Spark UI, then stages, then summary matrix. Second method, we can go like code level detection. This is the code. First, we will check how many records are in each partition. We have to go group by. The second step is check distributed of specific skew key. Example, if you suggest country is skewed, means group by country. Third step is after shuffle, means group by or join, check the shuffle partitions. So next point is when does data skew happen? Data is a skew is a data statics that become performance problem only during operations that group or co-locate data, means shuffle. Reading raw data usually fine. Spark split files into equal 128 MB chunks. After group by record with the same key land in the same partition skew. After join record with the same join key land on the same executor skew. After repartition, if you repartition by skew column, skew follows. The shuffle is the trigger. Stage 1, read plus filter, no shuffle, roughly equal partitions. Then if we do group by on country, cause shuffle. Stage aggregate shuffle result. Operation that cause data skew. First it is first group by or aggregation. If India has 80% of record, the India partition is massive. If we do the group by on country. Second, joint operations. If product P001 appear in 70% of order, means like order dot join in bracket column, join condition product ID and inner join, and product in product ID P001 value is 70% of the order, then it will occur. And after shuffle, like skew will happen. Then distinct and drop duplicate. If drop duplicates are clustered around the certain keys, the partition hold those keys become larger. The window partition. Next is why data skew is bad. Because straggler block the entire stage. In Spark, all tasks in stage must be complete before the next stage begin. Only slow tasks make all other executor core set ideal, wasting compute you are paying for. Second, uneven resource utilization. Then means suppose we have 4 partitions and 1 to 3 partitions done in less than 5 seconds, but fourth partition taken more than 60 seconds. So we have to wait for that before partition to complete. Third is out of memory error. Fourth is data split are expensive. Let's discuss about how we can fix the data skew. First is salting. It's most important and must know. First technique is salting, most important and must know. Add a random salt to the skew key to artificially spread it across multiple partitions, then aggregate into the steps. Basically, what we have to do, we have to import random function and spread each key across 10 partition, means salt underscore factor is 10. Then we have to add salt to the skew partitions, means suppose we have data skew is we have to group on country, then but India having more values than other countries. Then we have to with column we have to concatenate countries dash random factor, and then first level aggregation on salt, and after strip the slot and do the final aggregation. Second technique is broadcast join for join skew. If the smaller table is join is small enough, less than 200 MB, broadcast it all executor, no shuffle and no skew. For you got right, like means we have to import the broadcast function from the functions. Then product is small and product table is small, so we have to join based on broadcast, using broadcast to product to join based on product ID. Then configuration raise threshold if the small table is between 210 10 MB to 200 MB. So we can change also the broadcast table size, that using spark.config.set spark in brackets spark.sql.auto broadcast join threshold comma 200 MB. We have to give in bytes, like 20 crore 97 lakhs 15,200. Third technique is skew hint. Spark.3.0 introduce adaptive query execution EQE with automatic skew join handling. Here we have to enable the EQE by spark.config.set in brackets spark.sql.adaptive.enable comma 2. Then we have to also enable spark.sql.adaptive.skewjoin.enable true. Then EQE detect skew partition and split them automatically. The skew threshold partition size is greater than factor into medium. Fourth technique is increase the shuffle partition. And fifth, like if the skew is mild, simply increase the partitions, can dilute it. Then fifth is repartition before join. Manually repartition the skew data frame to redistribute data more evenly before the join. Repartition by composite key to spread the load. Fifth technique is filter plus union. Isolate skew key. Handle. Okay, so let's summarize techniques. Sorting techniques best for group by skew. It is complex and working in stream no. Broadcast join best for join with small tables. Complexity is low and working is streaming is yes. EQ skew join best for join skew. Spark function we have to use spark 3 dot plus 0 plus. Complexity is low means auto and working streaming is no. Increase shuffle partitioning best for mild skew. Complexity very low. Working in streaming no. Repartition before join best for join skew. Low complexity and we can use for streaming. Filter plus union best for non-skewed keys. Complexity medium, we are not using for streaming. So let's discuss about interview questions. First, it is what is data skew in Spark? Data skew is when data is unevenly distributed across partitions. Some partition holds significant more data than others. This causes contain tasks to take much longer than others, which hold up the entire stage in sync. Since Spark wait for all tasks to finish before moving to the next stage. How do you identify data skew using Spark UI? Two places. Event timeline means one task bar is dramatically longer than other. Classic symptoms like job stuck in 99 out of 20 tasks. Summary metrics: a huge gap between median and max of during an input side column. If max duration is 3x or more than median, skew is likely present. Next is which Spark operations typically cause data skew? Operations that trigger shuffle and group record by aggregations. Record with the same key go to the same partition. Next, join records with same join key are relocated to the same executor. Window functions like partition by in window space concentrated records by key, listing and drop duplicate, deduplication, shuffle records by specifying column. Next question is, what is sorting and how does it fix group by skew? Sorting depend on numbers, means the salt, the skew. Let's discuss, like I will repeat. Sorting depends on random numbers to skew key to artificially break one large group into multiple small groups. For example, India become India underscore 1, India underscore 2, up to India underscore 9 with the sort factor of 10. This spread 9 million India row across 10 partition instead of 1. You then you then do partition aggregation on the sorted key, split the sort and do in final aggregation. The cost is 2 aggregation passes instead of 1. Accessible trade-off for eliminate skew. When do you use broadcast join versus sorting to fix skew? Broadcast join when the skew is joined on the join and small table is under in 200 MB. This eliminates shuffle entirely, so there is no skew to worry about. It is simpler and should be tried first. Sorting when the skew is group by or aggregation, or when both tables are joined on large broadcast is not possible. Sorting required more code but work regardless of table sizes. What is AQE skew join optimization? How is it different from manual sorting? Again, what is AQE join skew join optimization? What is AQE skew join optimization? How is it different from manual sorting? Adaptive query execution means AQE Spark 3 plus detects skew partition at runtime by comparing each partition size to the median. When a partition needs skew factor into median default 5x, Spark automatically split that partition and process it in smaller pieces, essentially doing sorting automatically without any code change. The difference from manual sorting, EQ is dynamic, no code needed. Adapt to accurate actual data. While sorting is static, you hardcode that sort factor and key. EQ is enabled by default on Databricks. You are running sort merge join between 500 GB fact table and 200 MB lookup table. The join is skewed. What do you try first and why? First, try a broadcast join. 200 MB is a default above default 10 MB threshold, but with practical limits. Practical limits increase spark.sql.auto broadcast join threshold to 200 MB and add a broadcast hint. This eliminates the shuffle entirely, which is better than any skew fix that still involves shuffling. If the lookup table is genuinely 200 MB, compressed by expand significantly in memory, check driver memory, spark.driver.memory. Since the driver select the broadcast table, if broadcast is not feasible, a fallback to AQE skew join optimized since we are on Spark 3 plus or Databricks. In your iceberg migration project, you are migrating 500 GB table partition by event date. Some date having 3x more record than others. How do you handle this? 3 parts approach. Identify skew dates upfront. The query source table. Select event date, count star from source. Group by event date, order by count star in decreasing order, limit 20. Process skew dates separately with largest parallelism. First, we have to list down that month end dates, then for loop date in skew dates, Then we have to create the data frame using that skew dates and repartition 15 and write to the data target as a table, and append method we have to use. Then we have to list down the non-skew dates, means local identity columns values. For date in non-skew date, we have to read the table and skew filter the event date based on event date, and repartition 10 and write down into target table, and append mode we have to use. After migration, run optimize to iceberg table to compact small files created by over partitioning. Next question is sorting introduce two aggregation passes. What are scenario would this actually be slower than just dealing with skew? Again, sorting introduce two aggregation passes. In what scenario would this actually be slower than just dealing with the skew? Sorting can be counterproductive than the dataset is small. Means two aggregation passes on few millions records cost more than skew itself. The skew is mined if max or median ratio is only 2 or 3x. Increase spark.sql.shuffle.partition is cheaper. Third is network is a bottleneck. Sorting create more efficient, more shuffle partition, increase network traffic. If your cluster has slow nodes networking, this overhead can exceed the skew cost. Salt factor is too high. If you use salt factor is equal to 100 on 1 GB dataset, you create 10x 100x more shuffle tasks with almost 2 data each. Task scheduling overhead dominates. A rule of thumb rule is apply sorting when skew ratio is greater than 5x and dataset size is larger enough that to pass cost is enabled. Real world scenario, we have four real world scenario. We will go one by one. Group by skew in golden record MDM pipeline. In your MDM pipeline, you are deduplicating customer records using group by on country, source system, followed by complex aggregation to compute golden records. India accounts for 70% of records. The job constantly gets stuck at 199 out of 200 tasks for 40 plus minutes. Diagnosis how we can do, like we have to group on cluster, then take count, decreasing order count, and show. Solution is sorting plus AQE, enable AQE, then sort the skew column, then and spread India across 20 partition, means 360 rows each. Then first pass partial golden records computation per sorted key, then pass second pass is final merge after splitting sort. Result is job time dropped from 55 minutes to 8 minutes. सो बेसिकली इथं काय केलं आपण, इथं आपण सॉर्ट 20 घेतलं आहे, नंतर नवीन विथ कॉलमनं एक कॉलम बनवला आहे सॉर्टेड क्यू नावाचा, आणि त्याला कम्युनिकेट केले कंट्री अंडरस्कोर सोर्स सिस्टीम अंडरस्कोर रँडम नंबर दॅट इज 1 to 20. देन वी हॅव टू देन ती डेटा फ्रेमला आपण डीएफ अंडरस्कोर सॉर्टेड असं मेन्शन केलं आहे, आणि ती डीएफ अंडरस्कोर सॉर्टेड मेथड ग्रुप बाय केलं आहे सॉर्टेड कीनं, ॲग्रिगेटेड बाय updated at latest date. Then first email sum घेतला आहे ऑर्डर काउंट alias partition order count. Then final merge after splitting sort. मग त्या ह्याला विथ कॉलम परत सोर्स कंट्री सोर्स एक्सेप्ट केले सॉर्ट कॉलमनं, आणि ग्रुप बाय केले कंट्री सोर्सनं, आणि ॲग्रिगेशन केले लास्ट अपडेटेड ईमेल आणि पार्टिशन ऑर्डर. like that. Next scenario is join Skew in Delta Lake sales pipeline. Context is a Delta Lake pipeline joins orders table and having 500 GB 800 million records rows with product 15 MB size and 200K plus records on product ID on product flagship phone appear in 60% of orders. The join stage keep hitting out of memory on one executor. So solution, broadcast join. We have to increase that broadcast size like spark.sql.auto broadcast join threshold, comma. We have to give the 10 string. Okay. प्रोडक्ट म्हणजे काय केली तर आपण थ्रेशोल्डची साईज वाला स्ट्रिंग इन ब्रॅकेट 100 इंटू 1024 इंटू 124 जेणेकरून या 100 MB साईज दिल्या. प्रोडक्ट टेबल इज 50 MB, so we will within the broadcast limit. So we have to join based on using broadcast and we have to write the table. If product were too large to broadcast, then alternative is AQE, enable AQE, and then also more aggregation detection means SQL dot adaptive dot skew join dot skew factor comma in bracket string 3 in string 3 double quote string 3. Third is window function skew in time series partition. You are computing rolling 7 days revenue per company using window function. The job take 2 hours for India but 3 minutes for others country. So what we will do, spark from PySpark.sql.window import window programmatic all India rows for to go one executor means window is window space equal to window dot partition by country dot order by event date row between -6 to 0 comma 0, then df dot with column rolling revenue comma f dot sum in bracket revenue dot over that window space. So solution is process Q country separately. Process Q country separately means separate India 70% of filter 70% of data from other, and then we have to partition based on the country or event date order by ascending order and row between -3 -6 to 0. So India, this is the function we have to revenue. Okay, first we have to do India repartition 50 केल्यानंतर other India without order. Without India we have to create 2 data frame with India and without India, and then we have to apply window function to each separator. Then with India we have to create a data frame with column rolling window and combine that df is finally equal to India dot union in bracket other than India, and then we have to write to the delta table using overwrite mode. Quick reference data skew cheat code. So defect like spark if you want to check the defect, you have to go spark UI, then stage summary matrix, then max duration, in that median duration, and with code we have to go df dot with column PID comma spark partition ID bracket group by PID dot count. Cause we have to fix cause fix mapping, like if there is data skew we have to use sorting data join skew plus small table we have to use broadcast join skew plus both tables are large we have to use EQU skew join or sorting. If you have mild skew, increase the number of partitions, and no skew keys we have to use filter plus union, and window function skew we have to use separate plus union approach like this. Then AQE configuration, like database default on, then if AQE adaptive enable is good, true, adaptive skew join dot enable is equal to true, adaptive skew factor is equal to 5, lower than defect sooner, adaptive skew join dot mean partition size is equal to 256 MB. So this is about Spark Apache Spark data skew. That's is about this video. We will see in next lecture.